Hello people, welcome back to my channel. uh, Today in this video we are going to learn about 8086 microprocessor. Okay, so what is meant by 8086 microprocessor? What is meant by 8086 microprocessor? Okay, let us learn. 8086 is a 16-bit microprocessor. 16-bit microprocessor is called 8086 microprocessor. What is meant by 16-bit microprocessor over here? So 16-bit microprocessor means it is capable of working on 16-bit of operation in one 16-bit of information in one operations. That means it can perform at a time, it can perform 16 bits of operations. Okay, that's it. So uh, there are some of the easier things which will make easier for you to draw a block diagram and explain each blocks in microprocessor. First of all, learn about this memory. Okay, memory. In memory we will divide this memory into how many segments? Four segments. How many segments? Four segments, and they are code segment, stack segment, data segment, and next one is extra segment. Okay, this memory will be divided into four segments. That will be code segment, stack segment, data segment, and extra segment. Will be dividing this into four segments. Now let us draw an example. Okay, and there will be offset. Okay, why we use this offset? This offset is used in order to calculate the physical address of your any folders or file. Okay, we'll use this offset in order to calculate the physical address. So some of the example of offsets are IP, SP. IP means instruction point, stack pointer. Okay, and next one is IP, SP, DI, and EI. These are the sum of the offsets of MP. Okay, these are called offset register in microprocessor. In memory, these are called offset, and these are called segments. But in microprocessor, we'll be calling this as segment register and offset registers. Okay, so how do we calculate the physical address? We will calculate this physical address. Look, formula: segment into 10h plus offset. Segment into 10h plus offset. That means, suppose let's assume segment is 1000 and offset is also 1000. How do we calculate? Segment 1000 into 10h plus, so what's the value of offset? It's 1000. Okay, now we'll calculate it. 1000 into 10 equals to 10,000. 10,000 h plus 1000, that will be 11,000 h. Okay, this is the your real address of your file or folder. Okay, so offset is calculated. Oh, no, offset, physical address is calculated like this. Okay, so now there will be two types of address. There will be two types of addresses in microprocessor. In memory, there will be two types of address in memory. They are real address and virtual address. Okay, so now let us let us move towards architecture of 8086. Okay, we'll divide this architecture into two parts. They are BIU and EU. Okay, BIU stands for bus interface unit, and EU stands for execution unit. Okay, BIU stands for bus interface unit, execution unit. Okay, so why this 8086 microprocessor is divided into two parts? Because of pipelining. This 8086 microprocessor is divided into two parts. We'll cover this pipelining chapter in our next video, because it will be our video will be too long for that. Okay, so let us learn first of all about BIU. So what are the main functions of BIU? The main functions of BIU are to fetch data, number one. Okay, to fetch data or to fetch the instructions, and to calculate physical address, and next one is to manage the queue, to manage the queue. Okay, this okay, to manage the queue. Okay, so next one is segment registers: CS, SS, DS, and ES. These are our segment registers. Okay, CS, this is called CS, next one is called SS, next one is called DS, and next one is called ES. These are called our segment register. Okay, now let us learn about this CS. Okay, what does this CS do? This CS tells where the code segment in memory begins. Understood ना? Code segment memory में कहाँ पर start होता है वो SCS tells that. And what is the value of SS? What is the definition of SS? SS tells starting segment. This means SS tells the starting segment. DS and ES similar. DS for data segment and ES for extra segment. And what does this IP do? This IP contain the offset address. This IP contains the offset address. So if we combine this IP and CS, we will find our physical address. Understood not? Which is also called the real address. Understood? Now let us move towards our block diagram. Okay, this video is going to be too long. Okay, now first of all, see here block diagram of 8086 MP. 1 2 3 easier way to learn. First of all, code CS, SS, DS, ES. Okay, next one is IP. Okay, we'll be transferring this data upper side in order to calculate what already I have told you. We use this to calculate physical address. In order to now this data will be sent over here, CS, the value of CS, the value of IP, and it will calculate the physical address. Okay, it calculate the physical address and it will be moved towards memory. Here you will find your memory here. Okay, here you will find your memory, and this data will be fetched towards the queue. Okay, now look here, queue. This data will be sent towards queue. There will be 6 byte queue, 6 5 4 3 2. There will be 6 byte queue only. Okay, in microprocessor में 6 byte queue prefaced queue होता है. Understood not? In microprocessor there will be 6 byte prefaced queue. Understood? And this queue will be sent towards control system or control unit or anything you can call it. Okay, control system, control unit, and this will be moved towards data bus. Okay, this will be, now look here, already I have told you about two types. So this is called BIU. This is called BIU part. Okay, this look here. So this is called BIU part of an microprocessor architecture. Now we will be doing about dealing with EU. This is the most easiest part. You can do it. Now we will rejoin it. Okay, now from here. Okay, now look here. 1 2 3 4. For this 4 byte you can do like this. Okay, now look here, right here, A B C D, A B C D, H H H H, L L L L. Now what does this H and L means? H means higher byte and L means lower byte. And this ABCD, they are the general purpose register. What is mean a general purpose register? Those registers which can be used by a programmer, which we can use, and they contain each of 8 bytes, and in total it will be of 16 bytes. Similar B into this will be of 8 bits each. Okay, 8 bits. Okay, this will be of 8 bits each, and here you will find SP, BP, DI and EI. Okay, so now from here data will be moved towards ALU. Here you will find the ALU. Here you will find ALU, and this ALU will be of 16 bit. From here programmer will input a certain value over BH and BL or CS or CL as your wish, and this value will be moved towards ALU in order to perform some of the operations according to your design, and this will be sent to the database. Okay, that's it. And from here data will be go to operands or flags. Okay, so that's it. So this is these are our architecture of 8086 microprocessor. Hope you guys like this video. Okay, होप यू गाइस विल अंडरस्टैंड, आप लोगों को ये अंडरस्टैंड करने के लिए इजी हो जाए और आप लोगों के लिए बेस्ट ऑफ लक फॉर एग्जामिनेशन, स्टडी वेल. ओके गाइस, arigato.